So today I'm just first to introduce myself. Hi, I'm Jason, and I'm from Taiwan, and I'm currently working in the biotech companies, and that's my the all education experience. So I received my bachelor degree in chemical engineering and civil engineering, and from National Taiwan Universities in 2010, and then I moved to Cornell University to get my master's degrees in biomedical engineering and my PhD in biological engineering. So after I received my PhDs, I moved to Boston and joined the Boston Children's Hospital and MIT to become a research fellow and research affiliate. And then just 2 weeks ago, I left the MIT and joined the biotech company in Boston here called Modex Therapeutics. So as you can see, my background is very diverse. I received the trainings from the biologists, engineering, and chemistries, and that's very similar as what biomedical engineering is. Because biomedical engineering is a field combined with all these fundamental science. So, for example, if we are trying to do the most popular the lipid nanoparticles, what we need to do is we need a lipid that's a material to deliver the mRNA. So we need a chemist to synthesize those delivery vehicles. And then we need an engineer to find out the best formulations to encapsulate the mRNA and deliver to our bodies. And the last part is the biologist part, what kind of targets, what's the mRNA we need to design in the sequence and to reach our goals. So this biomedical engineering is a disciplinary the subjects, and what we can do is we usually collaborate with different experts. And so that's why if anyone want ask me is it good to study biomedical engineering in undergrad major, I would say probably not. Just wait until the graduate school, because you need to learn more in the fundamental science, no matter in engineering, biology, or chemistry. That's all. It's okay. I mean, you can at least get enough training from one majors, then you can move to biomedical engineering field to collaborate with different experts. So, for example, the MIT, that's two principal investigators, Professor Robert Langer and Professor Daniel Anderson. In their groups, we have a lot of different experts. To me, I'm also a biologist, engineers, but I always just work with the other chemists or even different engineers here. So the next is I can share some of my research experience. So if you are curious about what is biomedical engineering, maybe that's some examples for you. So because I have very broad research interest, so my focus is from nanoscale, the research, to the macro scales. In the nanoscales, it's pretty popular. The first is the lipid nanoparticles. And if you don't know what is lipid nanoparticles, just think about Pfizer or Moderna's mRNA vaccines. That's all based on the lipid nanoparticles for the mRNA deliveries. And the other part in the nanoscale size is we also develop using different kind of material to encapsulate the proteins, peptides for a nanoparticle to encapsulate this drug for the drug delivery purpose. So that's also another the topic if you are interested in the biomedical research. In my micro scales, that's my the major work at Cornell. It's I encapsulate a lot of cells inside hydrogel capsules and use for the cell therapies. For example, if that's a type 1 diabetes patients, and why the type 1 diabetes patients happens, that's because the patient's own immune system has some issues. They cannot recognize their own cells, so these immune cells trying to attack the pancreatic islets or pancreatic cells, which can secrete the insulins. So once all the pancreatic cells are dead inside the bodies because of the autoimmune issues, these patients can no longer secrete any insulin. So that's why they have very high blood glucose levels. And how we can treat this disease is how about we encapsulate the pancreatic cells and use the material to protect the cells from immune attack. Then we use these materials to allow the nutrients to diffuse into support the cell growth and cell functions. And then also we allow the porous will allow the insulin secret from the cell to diffuse out. So that means instead of inject the insulin shots, we can just implant those cells and ask the cell to work for us. So if we are eating more food that's a higher the blood glucose, so these cells can help us to secrete the insulin to respond to the blood glucose. So that's kind of the different the application in the cell therapies and also in my the cell encapsulations work. And the last one is the macro device. So I've talked about we can encapsulate cells in a hydrogel systems to protect the cells and allow the cell to survive and have the functions inside our bodies. But another thing is the capsule is easy to implant, but it's hard to retrieve because we cannot expect the cells will live forever inside our bodies. So what we can do is we design a bigger, larger the macro device to encapsulate the cells, and then it's easy for the surgeon to suture it into our body, so we can easily to retrieve this device to replace the cells for the future the replacement the cell therapies. And the middle one is we can also I work with an electrical engineer to design a new medical device, so we can precisely use a phone to control the drug release, and that's also pretty exciting. And the last project I work with artists, so we are trying to use to recreate the artificial ear for Vincent van Gogh. So we can see there's a Vincent van Gogh's pictures, and we know Vincent van Gogh cut his ear. So what we're trying to do is we want to combine the tissue engineering and also genetic engineering technology. So we find Vincent van Gogh's descendants to donate his ear, so not ear, the chondrocytes from his ear, and then we immortalize the cells, and because we use the 3D printing to print out Vincent van Gogh's the ears shape, so we seed those cells into the scaffold, trying to make the cells more close to the Vincent van Gogh's. And also we use the CRISPR technology, trying to overexpress some the creativity genes. So this this is not a science project, but it's fun. We combine the science and art together and trying to make an impact to also educate the public what is the CRISPR technologies and what is tissue engineering, what we can use in this the art projects. So this is all my the past experience, and hope this will give you some the idea what is biomedical engineering do, and also what you can do, what kind of research in the biomedical fields. So the next is this is the QA sections. There's some questions from the phones, so I will just answer from now, then I will open the question to people's. OK， 所以这是 QA 的 section。那有些如果是中文提问，我觉得直接是中文回答。那第一个问题就是，如想问 直博跟硕士的分析跟选择，1年的硕士足以去职场工作吗？是可以的，因为就是要看你未来想做什么样的工作。如果你是想在药厂做 R&D， 就是比较研发的部门的话，博士还是一个必要的一件事情，因为很多大公司还是蛮看学历的，你需要有学历才有办法就是往上继续爬。那1年硕士能不能去工作？可以，因为我很多台湾人在 Cornell 都是念1年的硕士之后就去药厂或是业界工作，所以是有机会的。但是我只会说，硕士的 ceiling 它的天花板大概可能就是 scientist 或是 senior scientist，就是等于是一个 PhD 毕业、博士毕业会拿到的 title。然后第二个问题是，大学成绩很糟，但是有一些不错的研究成果，是不是很难申请到好的学校？会有些很多学校会看 GPA，但是我之前如果有看到我写的文章的话，就会知道说，呃，美国有时候是老师的教授的权力很大，就是如果你能够先跟老师打好招呼，然后他也愿意，他觉得你的研究成果不错，他愿意收你，这样其实也是有机会的。所以，如果你是已经有不错的研究成果的话呢，可以试着跟一些美国的教授联系，或许这样他可以直接就是他如果愿意收你的话呢，通常学校都不会有太多的意见。不过你还是要符合就是学校的一些TOEFL 或 GRE 的一些最低标准，那是一定就是要达到，要不然就算老师要收你，他也没有办法。然后第三个问题是，读生物医学，有些人是在台湾读硕士、博士才出国，或是直接读博士。因为我自己的研究室经验不多，想先去美国读硕士再读博。请问您这领域美国硕博班的差异，要在硕班要怎么表现才能更有机会申请到博班？还有我是不是直接念博士？没有，我是先念一个硕士。其实我当初本来是想念一个 Master of Engineering，我就去工作了。我没有要念博士，是因为刚好2013年的时候的大环境也不好，所以变成是我出去工作，跟我念 PhD，呃，收入其实差不多。然后我就觉得，既然这样子，我就在跟很多不同的老师聊过之后，我就选择我要来念博士。那硕博有没有差异？其实看你如果是念的 Master of Science 的话，其实是差不多，就是你也是一样2年的修课跟每天要进 lab 做实验，最后要写一篇论文。那差异并没有太大。然后表现要怎么样更有机会申请到好博班？我觉得如果教授觉得你有潜力，或是你这2年的期间内你做的研究成果不错，你去申请其他学校，我觉得还是有机会。就像我说的，如果你已经来到美国的话呢，你去联系美国其他大学内的教授的机会会更大，因为对他们来讲，你就不是国际学生，你不是一个在国外的人，你是在美国境内，你是可以直接飞去跟他们聊天的，所以通常他们这样子的机会当然会比较高，因为他比较愿意能跟你多聊一聊。第四个问题，在生医领域里面有几间北美的大学享有较多的领域的资源？这其实就是跟我说，就是选学校的时候是要看你的所在地，你的 location 是有很大的关系的。像如果是要做生医或是生技相关的话呢，美国现在最 popular 2个地方，一个就是 Boston，那另外也是 San Francisco。所以如果你说最多资源的话呢，当然就会可能是从这边找。如果你是要去业界有关的话，就是 Boston 跟 San Francisco。当然有一些比较传统的一些学校，像 John Hopkins，他们也是有很多的资源，因为他们就在 NIH 旁边。 下一个问题 ，What should I do in high school if I want to pursue biotechnology? I would say take more like the biology course, like the math course, science course, and also I know some people will do the summer interns in the university. For example, at Cornell, I've seen like someone who are like the high school students just come to the lab, try to know more about like what's the biomedical research or what's the research life in the lab. So that's the chance you can do. And also like I'm not sure like which state you are in, but in New York State, they have the kind of the career workshop for the high school students. So you can attend this kind of workshop. Usually the states will collaborate with a lot of like the university. For example, Cornell will provide like several workshops during the summer so the high school student can attend and trying to explore their like the interests like in the math, in the science, in the biomedical research, and trying to find out what's their passion and interest. 最后一个问题是，请问美国生医领域 PhD 是否属于 STEM？是。目前发展市场导向趋势是如何？如果说市场方就是跟现在最 popular 的科技来讲，就是所谓的 mRNA therapeutics， 所以这部分可能就是要看现在，比如像药厂他们现在在主要投钱在做的方面是什么。那比如说从2017年开始 gene therapy 就变成是一个非常 popular 的一件事情，然后一直到 COVID pandemic 之后 mRNA therapeutic 又变成是比较 popular 的一个新的一个 topic， 所以这就是我猜这是应该你要问的问题。那与美国 PhD 的研究环境，研究环境我觉得你可能就能接触到很多新的资源跟新的技术吧，这我猜应该是你想问的问题。然后倒数3个问题是，如果国高中生有兴趣，需要准备什么？让他们知道该走什么方向吗？其实我觉得，就像我刚刚讲的，要看，就是如果你是在美国，不知道你是在哪一个州的话，要询问，因为很多政府其实都有提供这方面的一些关于 career 上面的 exploration 的探索，那就可以去让小孩去多接触不同的东西，去了解他喜欢什么。比如说，我们以前也去就是一些 science museum 去做一些 scientific show， 那这时候很多小孩子就会很有兴趣，或许可以带他们去多参与这种不同的事情，去找出他对哪一个方面是有兴趣的，再去培养可能会是最好。下一个问题是 What's the difference between bioengineering and biomedical? I would assume you are asking the biomedical engineering. That's the same, like it's just different name, like different school has a different like the name for a department for the majors, but actually that's all the same. Unless you are asking like a biomedical science. Biomedical science is more related close to the biology side. So that's the difference. Like if you are asking bioengineering and biomedical science, so the only difference is like one is like engineering, one is more like on like the biology or science part. 最后一个问题是，博士的研究主题跟硕士的方向不同，但是都在生意会不会比较不被接受？我倒觉得还好，是看，我其实不太清楚的不被接受的理由的原因是什么。因为其实如果你是在以说你申请博士班来讲的话，我倒觉得这不会是一个很大的问题，因为很多新的 topic、新的技术，其实都是从旧有的可能2-3个领域结合在成一个新的领域出来。所以我说，在美国的话，至少我不觉得这会是一个很大问题，除非你是一个差异非常大的东西，要不然你如果看我自己的 research，是我在台大做的东西比较偏体外的一些蛋白的实验去模拟 Alzheimer disease。那我在硕士做的是 microfluid device， 然后我在 PhD 做的是比较 cell and tissue engineering。那反正我到 MIT 这边做的是 gene therapy， 也都是大方向差很多不同，所以我会不会比较不会接受，我倒不觉得这是会是一个问题。那以上就是大概如果有填表格、有填问题的话，这就是大家所问出来的问题。那这是大概是我今天会我讲的部分。那如果有兴趣看一些我之前写过文章的话呢，这是我部落格的一些就是网址，大家可以来问。然后大家应该也都有我的 email，有任何问题可以继续来问我。